which again is a slightly unusual one that we've not had so far using a spreadsheet. So it will be interesting if we ever do get a financial spreadsheet like this. So Karen is saving towards her retirement, and there's quite a lot of writing here to read through, and we need to find out how much she will have to have saved by age 65. And then her retirement, she is figuring, will last her from her 65th birthday up until her 80th birthday. And she's working out her costs of living monthly. So we have an inflation rate of 2.5%, and there's also the interest rate of 4% that she could get on her savings. So we'll have to be careful here not to mix up interest rate and inflation rate. And fortunately they're telling us that we should get £243.960. So let's see if we can do this on the spreadsheet. So we can start by filling in some information. The time from age 65 to age 80, well, that's 15 years, so 15 times 12 is 180. We're given the inflation rate per year, which we changed to an inflation rate per month, and we've seen similar formulae earlier in this question paper, and a similar formula for the interest rate. Now, I always like to start with the months first. So we're going to go down from 0 months down to 180 months. And one thing to note here is that this is actually 181 separate payments if you count month 0 as well. The cost of living is £1,500, and this will increase each month by the monthly inflation rate. So we want to put a formula to multiply this by the inflation rate per month that we worked out, and we can just reference the cell above and use a power formula. So we'll multiply by this multiplier 1.00206 and put it to the power of the number of months. So it's like compound interest, except it's inflation. And we have the number of months in the first column. We should also round this to 2 decimal places because it is money, although I don't know how this would be marked in practice if a question like this ever did happen. And then double click and fill down the formula. Now for present value, again, we've never quite had anything like this in a exam. Present value calculations are done by dividing. So we'll take the cost of living and we'll divide by the multiplier. This time it's for the interest rate we're using. So 1 plus the interest rate per month, and we'll put this to the power of the number of months after age 65. So for the very first payment, that won't change. But then if we fill this down, we'll see that the present value calculation is reducing the value of the cost of living. So for example, at 2 months after age 65, it goes down from 1506.19 to 1496.38. So now to find the total, the sum of that column, and that's what we had to show. To do this properly, we should use the round function on these present values. So let's change these formulae to use round, and it'll just change the final answer by a few pence. So now let's look at part B, which is quite, again, more text to read. So she's going to be saving money every month from her 20th birthday all the way up to retirement at age 65. First of all, this is not hugely realistic, because you would never know that you would be able to save the same amount every month for 45 years, and also predict what the interest rate would be for all of that time. But anyway, we'll take the question as it is. So we need to fill in this savings account worksheet, and we'll use the 5% interest per year. So we can start just by guessing some contribution to her savings, £300 or whatever, and we'll do eventually we'll do a goal seek to work out what that contribution is. The percentage of the salary is the contribution divided by her salary. On a spreadsheet, you don't need to say times 100. You just make sure it's formatted as a percentage. Now the time until retirement, it's from age 20 through to 65, so it's 45 years, 45 times 12. So we can just type in 40 equals 45 times 12. It tells us it's 540 years. The interest rate per month uses a similar formula that we've seen many times before to convert from an annual rate to a monthly rate. Hopefully you're learning that by now. Now I've tried copying and pasting the required savings, and I didn't do this. I'm not doing this correctly, but you'll see later the correct way of doing it, because you see it's saying 0, which is wrong. Anyway, now we need to go and fill in the months. So it's 540 months. So we start at month 0 and highlight a few of them, and then click and drag down with the little black cross. Go down to, I think it goes down to 540, that's what we worked out, 540 years, so 540 months. Well, not actually, because her retirement is in 540 months, but on the time she retires, that's when she's getting her first payment from her savings. So she's not actually going to pay in on her 65th birthday. So we'll take out the final 540 month and just do it down to 539 months. So now I'm going to fix this reference, or this copy, because what I did I just copied, but that total required was itself a formula. So we don't want to copy the formula, we just want to copy the value. So you could do this just by typing in 243,959.37, or another way of doing it is to copy, and when you paste, do a special type of paste. So paste special, and then check the values box, paste values. And you can see that there's not quite enough space for the number, and it's displayed it all as hashes. I'll fix that in a moment. So the contribution to the savings will be the same, and that's an absolute cell reference to the number we made up, the 300. The accumulation is something we need to think about. And here, this is a very different kind of spreadsheet to the ones with loan repayments that you've probably done several times, because we're taking each cash flow separately and seeing what that cash flow will accumulate to at the end of it. The initial money coming in will be in for 540 months. The one coming in after 1 month will be in there 539 months. So one way to keep our formulae fairly simple is to add in an extra column. Now it seems like I'm trying to figure out where can I put the column in, but I'll just do it at the end, although it would make more sense to have it in the middle. And it's months to accumulate. So 540, take away the 0. So the first payment will accumulate for 540 months. There's a formula, it should have said months to accumulate, so I'll just fix that. Accumulation is equal to the cash flow size multiplied by the interest multiplier, so 1 plus the interest rate, and that's going to be to the power of the number of months, which is the 540. Now if we try filling this these formulae down, a slight mistake, because the 540 was itself a formula, so I'll just fix the one underneath it by taking away 1 each time, and we can see it goes down. The months to accumulate goes down as the time in months goes up. Now I'll fix the width of that savings column just by double clicking in between the F and the G. It makes the cell column wide enough for everything to fit. Total accumulation of savings is the sum of all of these accumulations. So we'll find out what the accumulation is with our guess of £300. And you can see with the £300 it's actually more than we needed. So we'll finish this question by doing the goal seek. So I'm sure you've seen this many times before. Go to what if analysis, goal seek, and the best way here is just to type in the number that we want it to be equal to, and we change the savings amount. And we can see that the contribution to the savings each month would have to be £123.97 per month, and that comes out as 4.77% of her salary. Now we could round that to the nearest penny, although it wouldn't change the percentage of her salary. And I won't go over how to print, but don't forget to print in value view and formula view and hand it in at the end of the exam. And now on to part C, 2 risks that could result in her not having enough savings to cover her living costs. Well, this whole calculation she did was based on her predicting that she would get a certain amount of interest on her savings, and also she was predicting what inflation would be. So both of these calculations, or both of these assumptions could have been wrong. Inflation could be more than she expects in retirement, which would make the whole present value calculation that she did incorrect. So inflation may be more than expected. That would be one risk. The other risk could be that the interest rates may not reliably be 5% or greater for all the time that she's doing this, so she wouldn't get all of the savings that she thought she would. And that's finally the end of this question.